So this is for integrated 2 for your algebraic methods to solving these problems on your final review. So we have unit 1 is over quadratics. We have unit 2 is over parallel lines cut by a transversal or angle relationships. And then unit 3 is about triangles and their congruence and similarity. Unit 1, probably the hardest of the 3 units because it's all about quadratics and there's a lot of steps to solving quadratics algebraically. So remember, you can use Desmos on a lot of these things, but this video is going to really more focus on how to do it algebraically and then where I think it would be the easiest to plug into Desmos but still get full credit. So for these first few problems, we are going to find x-intercepts and we're going to find a third point and we're going to write a quadratic in factored form. So this right here is factored form, and I'm going to do B because it's a little bit harder, and then I'm going to have you guys try A on your own. So this is factored form. The x-intercepts is where the graph crosses the x-axis. So -7, 0, and 4, 0. Our third point, the only other point that they give us on this graph is -8, 3. If they gave you an equation, this is where you would want to plug it into, or if they gave you other points, you could choose whatever point, but likely they're just going to give you a graph with x-intercepts and some other point. F of x is just another way to say y, so I'm going to write that as y. M and n are going to be your x-intercepts. So these guys are your x-intercepts. A tells you if it's going to be concave up or concave down, but it also tells you the stress value, and usually it's not given to us. That's why we have this third point to be able to find A. So far in our equation, we don't have A yet. X minus m, we're going to say x minus -7. And then x minus n is x minus 4. Our 2 x-intercepts right there. So -7, 4. And remember, in our equation we have negatives, so we're going to keep that as a negative. They change sign inside the parentheses, so this is really going to change to y equals a times x plus 7, x minus 4. If you got to here, I believe that this would get you pretty good on partial credit to be able to get the x-intercept and it's almost in factored form. Here's where the algebra comes into play, is plugging in this third point to find the a value. So I know that all points go in x, comma y. So I know that I can use -8 for x and +3 for y. And then the only thing I would have left over in this equation down here would be a, because I can plug in 3 here for y, I can plug in -8 here and here for x, and then I would just have numbers around a. So y is going to be 3, a we still don't know, x is -8 plus 7, x again still -8 minus 4. Simplify, so using PEMDAS, we'll do our parentheses first. 3 equals a, we didn't do anything to. -8 plus 7 is -1. -8 minus 4 is -12. This is where you could use Desmos as just to be able to figure this part out. I would probably just plug this into Desmos to be able to find your a value. But again, I'm trying to show you all of the steps. So 3 equals Negative 1 times negative 12 is positive 12. This is saying a times 12 to get rid of times we divide. So a equals, this simplified as a fraction, 3 goes into both 3 and 12. So 3 goes into 3 1 times, 3 goes into 12 4 times. Now we have our a value. Now we have enough to find our whole factored form. So taking from what we had in line 2, now we're just going to add in our a value. So y equals 1/4 x plus 7 x minus 4. Try a on your own. See if you can figure out the factored form and the a value of this quadratic by following along with these steps. So plug in m and n, plug in the third point to find a, write the whole equation with your x's and y's. So pause the video, try a, and come back to get the answer. Okay. -2, 0, and 2, 0 are our x-intercepts. Our third point is 0, 6. That's a nice third point because 0 is always really easy to work with. Plug in our m and n values. So again, I'm changing that to y equals a x minus -2 and x minus 2. Minus negative turns to a positive. Plug in our third point. So 0 is for x, 6 is for y. So 6 equals a times 0 plus 2, 0 minus 2. 0 plus 2 is 2. That's a terrible a. 0 minus 2 is -2. 2 times -2 is -4, so we have 6 equals a times -4. Divide by -4, since these are being multiplied. Divide by -4. Simplify the fraction if you can. So 2 goes into 6 3 times. 2 goes into -4 2 times, so -2. Now we can write our whole equation. Y equals -3 halves x plus 2 x minus 2. Sorry, hit a button. All right, next problem. Algebraically find the key points of the following quadratic and then plot all 4 points in to create a graph or a parabola. Show all work. So here I'm going to show you what I would do first is plug these equations into Desmos. Then I'm going to find all the points and then I'll show you how to do it algebraically. So if I plug into Desmos, I need to get Desmos up. We had x squared minus 6x plus 8. I can click on all the important points. I need to find the y value too. I'm going to keep that. And I can label it as well with this little checkbox. So there's all our key points. 0, 8 is our y-intercept. Oops. Two, 0 is one of our x-intercepts. 3, -1 is another x-intercept. Oh, sorry, I lied. That's not an x-intercept. That is our vertex. And the x value is our axis of symmetry. So the vertex is the full point, 3, -1. The axis of symmetry is x equals 3. So it tells us two things for the vertex. And then our last one I didn't label for 0 is another x-intercept. So there's all of our points, and we also can see that this is facing up, so this is concave up. Since our arrows point up, then we are now we're able to show some stuff algebraically. So I'll show you how to do it algebraically, but we have all of our specific points. We said it was concave up. X-intercepts were 4, 0, and I forget what the other one was. 2, 0, I want to say. Y-intercept was 0, 8. Our vertex was 3, 1. And our line of symmetry is x equals 3. So all that stuff we can find on Desmos. Now we just need to back it up algebraically. To find our x-intercepts, it either needs to be in factored form like this, or I need to factor it. So going back to factoring, we want to find what multiplies to 8 and adds up to -6. So I'm thinking through things that multiply to 8. I believe you guys have a little factor sheet. I think it's also on people's walls if I want to, I'm thinking about all the integrated 2 classrooms. But what multiplies to 8 would be 1 and 8. That doesn't add up to -6. 2 and 4, that's close. That adds up to +6. So if I make both of those negative, -2 times -4 is +8. -2 plus -4 is -6. Other thing too that I notice, since it multiplies to a positive but adds up to a negative, I know that these two numbers have to be negative, because a negative times a negative is a positive, and then if I add them together, they're going to come out to a negative. So that tells us that inside our parentheses we can have x minus 2 and x minus 4. If I set these equal to 0 using the zero product property, add 2 to both sides, add 4 to both sides, you get our x-intercepts of 2 and 4. X-intercepts always have a y value of 0, so that would be how I can find this algebraically. This one's a little bit easier because I can just set these guys equal to 0 to find these x-intercepts right here. We don't even have to factor it. All right, our y-intercepts. Y-intercepts, x is always 0, so if I plug in, so here's our x-intercepts, here's our y-intercept. We can plug in 0 into any of the x's, so x equals 0, we need to find what y is. I can plug in 0 squared minus 6 times 0 plus 8, which is very nice. 0 is a very easy number to work with. 0 squared is 0, -6 times 0 is 0, 0 plus 8 is 8. So our y-intercept is 8, where we get that 0, 8. We know x is 0 always for y-intercepts. 8 is what our output was. Our vertex, which also helps us to find the line of symmetry. To find the vertex, to find the x value, you want to use -b over 2a, so it's a formula. B in this case is -6, so a is 1, b equals -6, and c equals 8. B is -6, so x is going to be negative negative 6 is positive 6 over 2 times 1 is 2. 6 divided by 2 is 3. That's how we get this vertex 3 and the line of symmetry 3. To get the y value, we would plug in 3 to our original equation, or if you wanted to, into this equation. Doesn't matter. We'd get the same answer. So 3 squared minus 6 times 3 plus 8. I believe if you showed this and just plugged that into Desmos, same thing with like if you showed negative b over 2a and then plugged in the numbers and got 3 out from Desmos, you would probably get full credit. So 3 squared though is 9. Negative 6 times 3 is negative 18 plus 8. 9 minus 18 is negative. 9 plus 8 is negative 1. I think I missed that negative up here. So there's all our points. I am not going to plot them on our graph because this pen is not very good when I'm plotting, so I'm just going to leave the graph blank. So try B on your own. Again, we already have it in factored form, so we don't even really need to do this portion right here. We just have to follow along with the y-intercept and then finding the vertex. So try that guy on your own. See what you can come up with. Graph it. Pause the video. Okay, welcome back. Our concavity for this one is down because we have a negative 0.5 in front. Our x-intercepts are 3, 0, and negative 4, 0. Doesn't matter what order I have them in. Our y-intercept is, gotta find it, I don't remember. Six. Vertex is a little tougher on this one. So vertex, if you wanted to distribute these guys out, you could, but vertex in this case is going to be in between or the average of our x-intercept. So like right in between 3 and negative 4. So if I look at 3, oh, that's positive 3. Erase that. So negative 4 for one of our x-intercepts and positive 3. Right in between there is going to be our vertex and our line of symmetry. But in order to find it, I just need to find the average, which is 2 numbers of 3 and negative 4. So adding them up, dividing by 2 because there's 2 numbers, is going to be negative 1/2. So not very nice line of symmetry, which means our vertex is not going to be very nice either. If I plug in negative 1/2 into here, again, right here, I would say this would be enough work to give you the full credit to get the vertex. So if you already had the vertex from your graph, I think it was negative 0.5 and then like 6.125. Just showing this line right here would get you that full credit for the vertex. Okay, so a little bit different. I would say A is a lot harder because it's not in factored form and factoring is difficult. Okay, given negative 6x minus 7 squared plus 10, we want to find the following. the horizontal shift, the vertical shift, the stretch or vertical compress, the concavity, and then the vertex. So this is in what's called vertex form. And that is y equals a times x minus h squared plus k. Our horizontal shift is going to come from where h is. It is opposite of what you would think because there's already a negative in there. It's also what makes this parentheses 0. So if I think of like 7 minus 7 is 0, it's going to be a positive horizontal shift, or it's going to go to the right 7 versus what you would think it would go to the left 7. So h, our vertical shift, is going to be k. That one doesn't change. Our vertical compress or stretch is going to be dependent on a. If a is greater than 1, not with the negative, just the 6 value, then it's going to be a stretch. If a is in between 0 and 1, so it's a fraction or a decimal, usually it's going to be a compress. And concavity is going to be if there's a negative sign out in front, so a positive or negative a value. Vertex is h comma k. H is going to be the opposite. So in this case, we have a horizontal shift of right 7. So that tells me that my x value of the vertex is 7. Our vertical shift is up 10, since we have a positive 10 right here. This is a stretch because it's a 6. 6 is definitely greater than 1 of 6. Our concavity is down because we have a negative 6. And then the other portion of our vertex is this up 10, so positive 10. Try this guy on your own. Y equals 1/4 x plus 1 squared minus 3. So try that one. See if you can come up with that on your same paper, and then I will come over with the answers. Okay, so in green, I'm going to write the answers to this problem right here. This goes left 1. Since it's a positive 1, this goes down 3, so that inside is opposite. This has a compress of 1/4. It is concave up. Since this is a positive, there's no negative out in front of the 1/4. And then our vertex is -1, -3. Okay, expanding. We are going to use boxes for all of these guys. I'm actually going to do this middle one and then have you guys try the other two. So we're going to always have a 4x4 box for quadratics. And basically what this is saying, so since it's squared, it's saying x minus 6 times x minus 6. The same thing twice. So anything that's squared means it's twice. So if I had 3 squared, really that means 3 times 3. If I have -5 squared, that really means -5 times -5. So x minus 6 squared means I have x minus 6 times x minus 6. Then on the top, I'm going to put whatever one of these parentheses, doesn't matter, they're both the same, but like in this one I could put x plus 4 on the top, or x plus 3 on the top, or x minus 4. So x minus 6, x minus 6. And I am multiplying these guys. x times x, like I said up here, anything squared, x squared. X times negative 6 is negative 6x. Negative 6 times x is also negative 6x. Negative 6 times negative 6 is positive 36. Now we can combine like terms, which would be our negative 6x and negative 6x, which is going to give us our final answer of x squared minus 12x plus 36. So again, I'm just going to help you set up this one over here. It doesn't matter which one I put on top or which one I put on bottom, but I'm going to make a box of 4 because I have 2 things in this first parenthesis and 2 things in the second parenthesis. 2x and negative 1, 3x and negative 5. Try this guy on your own and see if you can come up with the correct answer. Pause the video, and then I'll throw up the answers for the left one and the right one. So 2x times 3x is 6x squared. 3x times negative 1 is negative 3x. Negative 5 times positive 2x is negative 10x. Negative 5 times negative 1 is positive 5. Combine like terms, negative 3x and negative 10x. Final answer, 6x squared minus 13x plus 5. This one, x squared, 3x, negative 4x, and negative 12, 3x, and negative 4x is going to be x squared minus x, or minus 1x, minus 12. All right, 5, more factoring. Just in general, our steps, first we want to see if there's a GCF. Then we want to set up our diamond of A times C adds to B. Then we want to if A equals 1, we basically can just then put it into factored form. If A doesn't equal 1, we have to do a little bit of magic. Okay. This first one, we have 5x squared minus 10x plus 5. I noticed that 5 goes into all 3 of these things, so I do have a GCF of 5, which means that's going to come on the outside of the parentheses, and then I'm going to divide everything here by 5. So 5x squared divided by 5 is just going to be left with x squared. Negative 10x divided by 5 is negative 2x. 5 divided by 5 is 1. Now, I know that A equals 1 here, so I can set up my diamond problem. What multiplies to 1 and adds up to negative 2? Only things that multiply with 1 are 1 and 1, but both of them are going to be negative because negative 1 times negative 1 is positive 1 and adds up to negative 2. So negative 1 and negative 1. Then our factored form of this would be keeping that 5 on the outside, x minus 1 and x minus 1.